quadratic graphs and their properties. The essential question excuse me, is what is the parent function of a quadratic, and how does the equation change when the graph is shifted? You're going to be hearing this phrase parent function for like the rest of your math career. Parent function. Well, as long as you're taking math classes, you're probably going to be hearing that phrase parent function. Okay, we have, like we've been talking with polynomials, they're standard forms for everything. Polynomial standard form is decreasing in exponent. Well, quadratic is very similar. The task you did at the beginning of class, what was the exponent on the formula in the problem? 2. A quadratic is a function whose highest degree is a 2. It's a polynomial with the highest degree of 2. So our quadratic f of x equals ax squared plus bx plus c. A, b, and c are just numbers. Okay? A, b, and c can be numbers. But it's decreasing in exponent in standard form as the polynomial, but the highest degree is 2. So if you see x squared and it's a polynomial, you should think quadratic. That's standard form. Okay, sometimes the quadratic is pretty simple. Sometimes we can have, by the way, we use f of x and y interchangeably. F of x just means it's a function. Do you remember from, I'm guessing, 9th grade, what a function is?
I do.
Okay, so each x can only have one y value. Yeah, so if you're in a functional relationship, when I taught junior high, I always talked about functional relationships. If you're in a functional relationship, can you be going out with 2 girls at the same time? Sometimes. Not if it's going to be truly functional. Probably not. Okay, so we know with functions, it's a function as long as the vertical line test holds, each x can only have one y. Okay, so when I say f of x, that's telling us it is a function, but sometimes we also write y. So I could write an example of a quadratic like this, y equals 3x squared, and that's still the same thing as f of x equals 3x squared. That's an example of a quadratic, because the highest exponent is a 2. Here's another example of a quadratic, y equals x squared plus 9. It's a polynomial with highest degree 2. Yep, and it has to have the square or it's not quadratic. If the highest degree is a 1, these are the ones you did last year. Y equals x. What type of a graph is y equals x? There's the word. Straight line. And we have a fancy word for line. It's called, actually starts with the 4 letters, line. It's called linear. Heard linear? So if x to the first power is our function, then it would be linear. Once we get x squared, it becomes quadratic. So here's the parent function. The parent function is the most basic quadratic, or the simplest quadratic. And the parent function for this case would be y equals x squared. That's the simplest it gets. From there, we can attach things. Like you can see in the example, we have a 3 as a multiplier. We can add things to it. We can subtract things from it. But it will still have the same basic shape that the parent function has. Y equals x squared. Okay, so I think we have one to figure out what it looks like. Oh yeah. We're going to graph this guy and see what y equals x squared looks like. When you're graphing, we need some points. We can do a table of points. Sometimes we do it vertically. Sometimes we do it horizontally, based off of what space we have. When you're graphing, you should get at least 5 points so that we can see the shape of the graph. Okay? When we're starting, often we're going to use -3 to +3 because it's nice and it's around the origin. Okay, -3 squared. What's that? 9. So if we plug in -3 into our parent function, we get 9. We do -2 squared. Caesar, what's -2 squared? It's -2 times -2. Good. +4. All I'm doing is taking my x value and plugging it into my parent function. Okay, then we do -1 squared. Taylor, -1 squared. 1. 0 squared. 0. 1 squared. 1. Then we get 4 and 9. And you see a pattern. You see something happen with all those blue y values? They repeat. They go down. And then all of a sudden it hits the lowest point, which that lowest point will have a name. And then it starts going back up, and they start repeating. So we're going to graph. You don't understand what? Oh, snap. We're going to graph these points to see what shape it takes. So I think that's the next question I have right here. What shape does this quadratic look like? So when we graph, very neatly, draw an x and a y axis. Don't draw this so itty-bitty that you need like a magnifying glass to see it. We always label, notice I have arrows on the ends too. We always label x and y. The x's we're looking at is -3 to +3. So sometimes when people do their graphs, they don't space it out very well because they start on the left and they put like 3 tick marks there, and then there's all the space before the origin. So if you need help evenly spacing them, start at the origin and work out. Start in the middle at the origin and work out -1, -2, -3. And you have to number it so we know what you're counting by. And then go back to the origin, and then go +1, +2, +3. Evenly space those. Same with the y. The y, what's my smallest y value on my table? That's the largest one actually, 9. 0. So I don't need to mark any of the negatives, but I start at the origin and go up to +9 at least. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I label one of them so I know what I'm counting by. So I labeled the 5. I like to make my 5 a little longer so that it's easy for my eye to jump every 5. Okay, if you plot those points, this is a point, right? -3, 9. Sammy, can you tell me how to move to get -3, 9 if I'm at the origin? -3, 9. If I start at the origin, how would I move to get to that point? Okay. Great. Left 3, up 9, right there. And then we do the same with all of them. -2, 4. Be left 2, up 4. Any questions so far? -1, 1. 0, 0. 1, 1. 2, 4. 3, 9. And if we connected those, what shape would take place? Yeah, it should be a U. So right here at the bottom, that minimum point, make sure it's not sharp V, because that's a different function we'll learn later this year. Make sure, especially at that bottom part, you curve it like a U. I missed the point a little bit. shape of a quadratic look like? It looks like a U. Okay, we call this U a special name. Has anyone been introduced to this before? Yeah? Do you know what it's called? Do you know what it's called? Well, it's non-linear, that's true. It starts with a P. We have a fancy word for it. It's called a parabola. Have you heard of that before? Okay, good. Parabola. Okay? You can fold a parabola. That's that word again. Write that down. You can fold a parabola so that the two sides match exactly. What's that called? When you can fold something right in half and it matches up with itself. Symmetric, and it means the graph has, we don't say the graph has symmetric, that sounds funny. Symmetry. Symmetry. The graph would have symmetry. You can fold it right in half, Brian. The graph has symmetry. You fold it right in half, and everything matches up with each other. Okay, so, yeah, this gray box got placed. The fold line that divides the parabola into two matching halves is called, do you know what that's called? Right here. You can fold. Oh, it's really close. It's something like the symmetry line. It's called. Exactly. Let's put it in a different order. Well, axis. Actually, we call it axis. So this fold line where we can fold it right in half is called the axis of symmetry. Axis of symmetry. The fold line that divides the parabola into two matching halves is called the axis of symmetry. This is vocabulary you have to know. So make sure you're writing it down. There's another vocabulary word. I think this is our last vocabulary word for the day. The highest or lowest point. Since we have a U, there is a lowest point. Sometimes the U is flipped, and that would make it the parabola at the top would have a highest point. That's called the vertex. Have you heard the word vertex before? Yes. Good. Some of us have heard it. The vertex. The highest or lowest point of a parabola is called its vertex. So parabola, axis of symmetry, quadratic, vertex. Those are all our new words today. Okay, so I have a graph here. What are the coordinates of the vertex? Vertex, remember, is the maximum or the minimum points. So I want you to turn to your neighbor and discuss what are the coordinates of the vertex. Turn to your neighbor, please, and discuss what are the coordinates of the vertex of that graph. Okay. Jessica, tell me when to stop when I would hit the vertex as I rotate around the function. I didn't hear you. Say it again. No, that's not the vertex yet. There we go. That guy is the vertex. What are the coordinates of that point? Zyroneth? What'd you get for the coordinates of that point? 0, 3, thumbs up or thumbs down. What do you think? Good. Or is it supposed to be 3, 0? Where's 3, 0? Yeah, that's 3, 0. Okay, good. So our vertex is 0, 3. You can also find the vertex by looking at a table of values. We actually secretly did that up here. Where is it? Right there. You see that turnaround point? is the vertex. So in this case, the vertex was 0, 0. So I believe on your homework you have to look at graphs and identify the vertex, then you have to look at a table of values. So you're looking at the y, and when y all of a sudden turns around, that's your vertex. It'll be either the lowest y or the highest y, depending if it's concave up or concave down. Concave up means it opens up. Concave down means it opens down.
I think I was looking with model kind of like that. It said the coordinates is negative 0 and negative.
Domain?
Yeah,
we're doing a little domain today, I think. Okay. Example 2. Graphing something that has a multiplier. Uh-oh, it's not writing. The board's not working. It's weird. Okay, well, while my board comes back on, write example 2 down. Graph the function y equals 1/3 x squared. Actually, here's, Brian, look, this popped up, domain. Graph the function y equals 1/3 x squared by making a table of values. Okay? Table of values, we need x and y. Now with our table of values, who likes decimals and unpretty numbers? Only a few people. Okay. Well, for me, I don't. On this one, since we have a fraction 1/3, fractions are division. See that divide by 3? The x's I'm going to choose, if I want to be nice to myself, would be numbers that we can divide by 3. If I choose something like 2 and I do 2 squared, 4 doesn't divide by 3 very pretty, right? So I'd probably use, what's the number that divides by 3? Okay, 6, 3, 6, and 9. So I'm going to use -9, -6, -3, 0, 3, 6, and 9. So it's always centered right here on this origin for today's assignment. The origin is at x equals 0. So if we plug them in, sometimes it's nice to do a little scratch work on that side. 1/3 times -9 squared. 1/3 times -9 squared. Please excuse my dear Aunt Sally. We would do the parentheses and exponents first. -9 squared is 81 divided by 3. That should come out nicely. What's 81 divided by 3? 27. Is that right? Hey guys, if you don't have calculators, you need to come get one. I don't want to be laying around. Everyone should be participating. There's plenty of calculators. If you need a calculator at the beginning of the day, you should pick it up. Thank you. Okay, we're going to do the next one. 1/3 times -6 squared. Well, -6 squared is 36. We have 36 divided by 3, which is 12. Then we have 1/3 divided by -3 squared. -3 squared is, no, -3 squared is 9. Divide by 3, then we get 3. Then we do it again. 1/3 times 0 squared. Well, anything times 0 is 0. What's going to happen when we plug in a positive 3?
Same.
Who said same? What do we get that's the same?
The same value.
Same value as what?
So we get 3.
Because it's the same value as when you plug in -3. Because -3 squared is the same as 3 squared. So that's your turnaround point, which tells you 0, 0 is called your, what's that vocabulary word? Vertex. That's your vertex. So once you know the pattern, you can just repeat it. Okay, if we were to graph this function, We need to draw ourselves an X and a Y. Actually, look at my Y's. Are any of the Y's negative?
No.
No. So I could do just an upside down T. I don't have to draw the negative part. Well, and I have arrows and I label X and Y every single time. On my X's, I don't have to count 1, 2, 3, 4, 5. I could count as long as I label. I could count, again, I start in the origin and work out. -3, -6, -9. As long as I label, then I know what you're doing. Start in the origin, work out. +3, 6, +9. The Y values, who wants to do 27 little tick marks? What's something else we could count by instead that would hit 3, 12, and 27? Counting by threes, as long as you label, it's good. 3, 6, 9, 12, 15. Oh, I do those little too. I'm going to run out of room. Okay, let's try this again. 3, 6, 9, 12, 15, 18, 21, 24, 27. Now when you plot your points, it should form a U because we are graphing the vertex. So we should see the turnaround point. Make sure when you draw in the curve, it is curved like a U. It should not be a pointed V. It should be curved like a U. -6, 12. -3, 3. 0, 0. And then we have symmetry, so you can just come too high where?
The middle one's chapter 1 down.
Oh, it's on 12. Okay, thank you. Fix that guy. And then 927. Please draw your points large enough that when I draw the curve through them, they're still visible. Don't do points so teeny that when you draw the curve through them, they disappear. Because we need to make sure you're actually putting points in the right place. It sounds like you've already done domain and range. Domain is the spread horizontally. So I like to put a little X to remind myself I look on the X-axis only. How far to the left does this graph go because of the arrow? Negative infinity. And how far to the right does this graph go because of the arrow? So we'll never actually reach infinity, so we use parentheses. Negative infinity to positive infinity. The range is the vertical spread. I like to put a Y, so remember I'm looking at the Y-axis. That's the vertical axis. And it's always lowest to highest. So what's the lowest point this graph goes to?
0.
0. That is the bracket. Why is it a bracket?
Because it goes exactly to 0.
Yeah, there's an exact point there at 0. And then how high up on the Y-axis does this go? And then what goes with infinity? Parentheses.
How do you type that domain again?
Domain is spread horizontally. How far to the left and how far to the right, looking at the X-axis. So it goes to the left forever because of the arrow. Just little by little. Okay, because of time, we're going to do this one with our calculators. Grab your calculators. Everyone should have already picked them up. We have 3 functions. We're going to type in our calculators and see what changes. This last one is the parent function. Okay, so I have a calculator here as well. We're going to type in the parent function first. Then the second one will put a multiplier of -4, and the other one will put a multiplier of +1/4. So, first thing, my calculator already knows in the wrong mode. Would everyone hit that mode button, and make sure the third line, that degree is highlighted. Mine has radian highlighted. So I'm going to go down and make sure degree is highlighted. I just pushed enter on it. Oops, it didn't work. Make sure degree on that third line is highlighted. Well, go down to degree and make sure it's highlighted. Okay, there's a y equals button, top left. That's our graphing. Everyone hit y equals, please. Clear out anything that's in there. The first one we're going to type in is our parent function. You have calculator? You get calculator. X squared. If you have a calculator like mine, there's your x right there by the green alpha button. X, the squared is kind of diagonal up from the 7. X squared. So x is right here by the alpha button. Squared is right here, diagonal from the 7. Now arrow down to where it says y2. Let's put that second function in. I think it was -4. So put negative, and you can't use the minus sign for negative. Negative is down by the decimal. -4x squared. Now, to make sure everyone's windows are in the correct place, if you would please go to zoom. That top row has a zoom button. And we want zoom standard. Number 6 will give you a standard window that's -10 to +10, vertically and horizontally. Zoom standard, number 6. And it will graph it for you. Here is the original parent function. Then when we times by -4, two things happened. The original parent function is up top. This one right here is y equals x squared. This one down here is y equals -4x squared. What happened when we multiplied by a -4? It went skinnier. So that's called a vertical stretch because this is kind of like your slope in a way. And something else happened. It flipped down. What do you think made it flip down? The negative sign. Okay, let's graph one more. The 1/4 x squared. Go back to y equals and go down to y3. Whenever we have fractions, we're always going to put them in parentheses. Parenthesis, 1 divided by 4, close the parenthesis. Fractions go in parentheses. So when people ask me, especially on the Q&A, some of you ask, how do I type in fractions on the calculator? Use the division sign, and you put it in parentheses. Parenthesis, 1 divided by 4, parenthesis, and then we do x squared. Now, we've already fixed our window, so you can go hit graph, which is top right. And it's going to do all 3 of them. There's going to be one new one, though. There's the new one. What happens when we multiply by a positive fraction? It gets wider. If we were multiplying by a negative fraction, it would get wider and it would flip. So, on your notes. When we have a multiplier, A does a few different things. When our A is a multiplier greater than 1, it gets steeper. The graph is a vertical stretch. Steeper. When A is a fraction, I'm going to put absolute value A because whether A is positive or negative, if it's a fraction between 0 and 1, the absolute value of it between 0 and 1, it got wider. That's called a compression. If you smush something down, does it kind of ooze out sideways? Yeah, if you smush something down, it oozes out sideways. That's a vertical compression. It gets wider. Compression or wider. And the last thing was if A was a negative, what happens if A is less than 0, meaning it's negative? What? It goes down. We call that flips. That's very important. I will be talking about this A for the next 2 years. And in calculus. I will still talk about this. This multiplier, it happens on every single function. If you have a multiplier, it does the exact same thing on every single parent function we talk about for the next 3 years. Okay, really quick on your calculator, one last thing to add in. What if we add something? I'm going to erase these guys. And I'm going to take my x squared and add something to it. Oops, it didn't work. X squared plus 3. Look what happens to the graph. There's the original. If we add, what happened to the graph? The vertex moves up. That's called a vertical shift. What if I had subtracted it instead? Any hypotheses what's going to happen? Vertical shift? Down. So another thing you need on your notes and then your set is when we call this a K. AH and K. We'll do the H next time though. If there's anything added or subtracted, if we have a plus K, that's a vertical shift up. If we have a minus K, that is a VS stands for vertical shift. That would be writing VS a lot. Down. Okay? Here's your homework. Page 116, 1 through 16, 18 through 36, even. Bring questions on these quadratics next time. And the assignment that is due is your, the one we answered questions on today, on the special cases, multiplying special cases. Oops, that's the wrong thing, sorry.